Now let's go for the results as we are already done with the solution. For that, double click the results. This will be the post-processing section for our project. We'll be observing different outcomes of our project. So here is our domain. Here is the inlet, the outlet, and the wall. This is our domain. At first, let's see the velocity contour. For that, we'll be needing a plane where we can observe our contour. So we'll be inserting a plane. In the domains, let's go for all domains. And in the method, we will have to select either of the three planes. We need a plane at the mid section of this pipe segment. So I think we will be requiring XY plane. So let's go for XY plane and let's keep the distance at the Z axis 0 so that the plane is constructed at the middle. Okay, you can see it here. Now we have the plane exactly at the mid section of this pipe segment. Now let's make a velocity contour in this plane. For that, go to this contour. Then we will have all domains, and in the location we are going to keep the plane which we have just made, and we will be going for velocity. Okay, we will have 11 contours and go for apply. Now the velocity contour can be seen here. Here the different colors represent different magnitude of velocity. Starting from blue and increasing towards red, the velocity is increasing. At the sections with blue color, we will have minimum velocity, and at the section with red color, we will have maximum velocity. Likewise, we can observe the flow vectorically, where we can observe the arrowheads, which will represent both the magnitude as well as direction of the velocity. We can observe that vector plot in the same plane. For that, let's go for vector, all domains, and in the location, let's select the same plane, and let's have equally spaced arrows, and let's keep the number of point 25. Our variable will be velocity. And in this color section, go for variable. We'll have velocity as our variable, and let's apply. We are seeing our contour here, so remove the check mark from the contour, and here we can see arrows of different color. Let's make these arrows a bit large. So let's go for arrow 2D, and let's increase the symbol size. Now the sizes of arrow seems a bit bigger. Now let's go for more number of points. Let's go for 100 points. Okay. Now these arrows are representing both the magnitude as well as direction. It can be seen here in this leader part. It shows that the arrows with red color will have maximum velocity. The next thing we'll be seeing is streamlines. So for that, let's remove the check mark from vector and plane. Let's go for streamline. Okay, we will have 3D streamline for all domains, and we'll be starting from inlet. We starting from inlet, it will go towards the outlet. In number of points, let's see a single streamline. So go for one. In the color, go for variable, and in the range we'll have local. Okay, apply. Okay, now this is the single streamline. It is showing the flow of a single fluid particle. We can also observe the flow through this animation window. Let's go for streamline 1 and let's make it a bit slow. Let's play the animation. Here you can see a single fluid particle going towards outlet from inlet, and likewise the leader showing the increasing velocity. Now we increase the number of streamlines to 25, and you can also see the animation of this flow through this window. Now let's also go for a chart where we will be seeing the variation of velocity in this streamline in x direction. Okay, so let's give the title of the chart. Let's name it velocity graph. And in the data series, we will have to select the location. Let's go for streamline. In this streamline, we are seeing the velocity variation as the streamline goes towards the x-axis. And in x-axis, let's select the x itself. And in y-axis, let's go for velocity. And the remaining parts, let's leave them as they are. And okay, here you can see the variation of velocity as the flow marches forward in the x direction. And like this, there are many other things which you can try out by yourselves in this post-processing section. Now at last, let's see the function calculator, which can be useful. Here we can see the values of different functions like mass flow, pressure, torque, velocity, and many other functions at different locations. So for an example, let's see the mass flow at outlet. Okay, we have our mass flow at outlet minus 100 kgs per second. The minus sign indicates that the flow is going outwards. While doing our setup, we had given the mass flow at inlet to be 100 kgs per second. So from here we can see the mass conservation in pipe flow. With this, we have come to an end of a small series of this simple project. We saw a simple fluid flow in this pipe segment. Now, to your information, CFD is a very vast concept. We can go deep into it only through practice. Only practice will make you better and better. Some people have spent their lives learning and enjoying CFD. It is just about to what extent you are going to be good at it. And as said earlier, with experience and learning, we can get better and better. So let's end this small series, and we will be updating this series with new CFD videos. So, goodbye.